Hello and welcome to Topper Machine. I'm Josh Topper and today is Wednesday, our follow-up video. If you're new to the channel, we always do a follow-up answering viewer questions and comments. And there were a lot of good questions in this video. A couple of stupid ones as usual, but a lot of really good ones about my tool holder that I made. And if you stick around, watch Saturday's video, I put this sucker to use. And it was very useful. So there were a lot of great questions. Let's dive into them. So as usual, I got my phone up here with the comments that were great questions, really just great questions. And if I didn't respond to you, that means we're going to follow up with that question. So to those of you that I did not respond to, the first one here, we'll start here with, just curious, what kind of life do you expect to get out of each cutter? Also, can they be sharpened? One more question, what is the minimum Rockwell C the insert would need to be durable? I really like this video. It makes me think about other possibilities. Thanks. So, what kind of life do I expect out of these things? Surprisingly, I wasn't expecting a lot. Considering what I was going to be doing with them for the first job, the paying job that we made the tool for, I wasn't expecting a lot, and we did see some issues, and that was actually brought on because of a bad tool grind on another operation that left a burr. So I had to actually grind a high-speed steel bit to get in, and then it left a burr, and it was hard. That I had to go back and attack with carbide to get through it, but it chewed right into this insert. And these were hardened to a Rockwell 64C. So they were hard. They were very hard. Now, just because of that little spot doesn't mean the rest of the insert is shot. I was actually able to rotate it and finish the job with that one. So that was one of my 1 1/8" ones that I made that I needed for that job. I made 3 of them just because I didn't know how they would hold up. Can they be sharpened? Absolutely, they can be sharpened. If you got a fixture on a surface grinder, a tool and cutter grinder, you can rotate them, you can sharpen them. Not a big deal, but they perform beautifully. Just the machining I did on them, the relief, the step in it for the chip breaker, they performed flawlessly. Couldn't have asked for better. And then, what is the minimum Rockwell C the insert would need to be durable? That one I don't really know where it needs to be. I would say probably in the 50s. You know, that one job I did was 1018. And then my piston that I'm doing this weekend's video is 7075 aluminum. I would say 40 to 50 would probably work, but we wanted to get it as hard as possible for the durability, and that's why we went to as high as we could with A2, was 64, 65, somewhere in there. All right, next one. Do you plan on grinding the inserts for sharpening, or are they sharp enough as is? Well, I covered that. They worked flawlessly without any additional grinding. Couldn't have been happier. What kind of school did you go to learn how to do that stuff, and did you just learn from doing it? I started out in a small tool and die shop in high school, and I learned from an old timer that knew his stuff, very skilled, very knowledgeable, and I learned as much as I could before moving on to the next job where I started working in bigger stuff and learned from a couple of really great machinists there who to this day are friends of mine. You know, I learned from some really great guys, different ways to do things, that non-conventional ways that really have proven to work extremely well. So mostly by getting into it and diving in and working with those that know what they're doing. School, I'm not going to knock it for a lot of things, but they just don't teach you real world application, like getting in a job and doing it. So get a job in a machine shop and learn from the old timers. That's the best way to do this stuff. So this guy was suggesting using medium pressure air blowing on the cutter to blow the chips away. Yes, I do that in certain applications, but it's not always necessary. Will you send the holder out to be heat treated also? No, and that's why I went with 4140 pre-hard. So the tool holder itself was 4140 pre-hard. That is between a 28 and 32 Rockwell C hardness. It is a very durable material. and it's, like I said, pre-hardened. It's a fairly tough material. It works great for a lot of tools, pins, things like that. It's a very good material. Bushings, you can use it for bushings too. Very good material. So this one kind of goes with that. Is there any reason for not making the holder from bar stock and have it hardened instead of cutting tool steel? Love the idea of making the large round cutting bits. I'm thinking I'm going to make some for myself. So again, going with the 4140 pre-hard, we did not have to do any of the heat treating of bar stock. So it was just a way to keep the time to a minimum. The tooling needed to be built as quickly as possible. I made the inserts, ran them down to my heat treat shop, which is another shop, the CNC shop I work with. They have in-house heat treat. They did that for me. I got them back the very next day, and when I got them back, I already had the tool holder done. So that worked out extremely well. And I was able to then get that job done that afternoon. So it just worked out so well. Making the inserts and then making the tool holder and doing all the heat treat, it may have been an extra day. So it wasn't worth it to me to do it that way. And like I said, the 4140 pre-hard is a very durable material and works great for this stuff. So that pretty much answers all the questions that we had on this tool make. It was a fun build. You know, it was building your own tooling in the shop. You know, that's what a machine shop is all about. You're saving money on building the tooling you need. Now, there was some comment, and so the funny thing is I didn't know this stuff existed this large, but that doesn't matter because the sizes that are available commercially in a insert like this were not available for the size I needed. So I needed some 1 1/8" ones for a 563 radius. I made 1 1/4", 1 1/8", and 1 inch for this holder. With the commercially available stuff, I would need 3 different holders. So this just works out better. I think there was a comment about somebody worrying about the insert moving. Once that bolt was drilled very close, held very close, fine threads, locks down tight, it doesn't move. And once you get butted up against that, if there is any give, it's not going anywhere. So this worked out extremely well. A very cost-effective solution versus buying a tool holder, buying the inserts, and then waiting for it to all show up, which would have been time. So a day and a half, roughly, to make everything and do the job that afternoon. So 2 days total for make the tool and then do the job. Was way better than waiting a week, 2 weeks, 3 weeks, whatever it would have been. Now on to the stupid questions. We had a couple of really, really dumb ones that commented on the chips on the floor. This is a working shop, not a hobby shop. If you want to see hobby shop work, there are a lot of YouTube channels that do that kind of work. Some very popular ones, they're hobby shops. They are not working job shops like this. So if a couple of chips on the floor or on the machine offend you, this is not the channel for you. So I don't have time for comments like that. It's very disrespectful of you to comment like that, and you're not welcome here. So that's all I have to say about that. If you really have a problem with the chips on the floor, feel free to stop by, come sweep the floor for me. I'd be more than welcome to have you here and sweep the floor. And you might learn something about what a job shop really is versus a hobby shop. So I hope I answered everybody's questions about the build of this tool. Like I said, it came out beautiful. I couldn't be happier with it. It did 2 projects flawlessly. 1 paying job, 1 job of my project of my own that we will be that'll be the video Saturday, so stick around. That is the piston for my Baker steam traction engine. 7075 aluminum, 9 inch, just under 9 5/16 inch diameter. So that came out beautiful. Be a good video Saturday, so stick around. A lot of cool stuff coming. Thank you for watching. Thank you for sticking with me and helping me grow this channel. And until next time, get out in your shop and get it done right the first time.